So now let us go into the wall buildups. So we could have now our situation with CLT. We're using CLT as a material, and we're having here now our buildup. We're using a thermal insulation layer of 75 millimeters for a temperature range from 0 to 45 degrees. This 75 millimeters of thermal insulation in a CLT construction can be used in that temperature range. If you're in that temperature range, with your climate data, with the highest temperature and the lowest temperature, this is the buildup. So you're having the CLT. Then because of panel construction, most of the times the air tightness is done externally, and now like externally on the CLT, because the CLT is panels, and it's so much easier to do normally an external taping than internal taping on this type of construction. I explained that more when we go into detailing instead of internal. And now you can have an exposed CLT corner internally. Yeah, from an architectural point of view, you could have this corners exposed. You don't need to put an ugly tape on it. Yeah, you just tape the CLT externally. And then we have here our weather tightness. We showed here now external brick facade. We can do that. Obviously, each one of these anchors is a thermal bridge, and we have to allow for it. And then we're having here a membrane on it. So now let us go for a harsher climate. Yeah, we're having now a harsher climate with minus 15 to plus 60 degrees. So now all what we have to do is increase the thermal insulation thickness. You see the structure hasn't changed. The only thing that we have changed here is now that we use now a different finish. It's a ventilated facade again, and you just choose your finish. If you want to use brick, you use brick. If you want to use a panel system externally as a finish, you use a panel system. If you want to have weatherboard, you use weatherboard. It doesn't matter. It's not a part of the thermal envelope. Yeah, and now we're having a range from minus 15 to 60 degrees. The only thing that has changed is the thickness of the thermal insulation. The detailing, everything is exactly the same. There is no difference. And you just choose your finish externally as you want it. I don't care what you do with your ventilated facade externally. You choose your finish. If you want metal, you use metal. If you want to use a gold platter, use a gold platter. If you want to use cement fiber externally, if you want to use timber, if you want to use whatever, I don't care, natural stone, brick, you use your finish whatever you want. Total freedom in your design. And you already can go up to temperatures of 60 degrees. Here to do is increase the thickness of our thermal insulation layer. The difference from here to here, the only difference is the thickness of the insulation layer. If your PHPP is now telling you 75 millimeters is not sufficient, then you go to your 80 millimeters or 90 millimeters, but there is no difference in the buildup. So it's simplified, guys. We're having here that situation, that's normally the range. We're having this situation, that's normally the range. And we have this situation. Our form factors, our shapes, our window quantities, and all that stuff has an impact. But generally, that's what we can use. Okay, so that's the way that we are looking at it. We're not looking at it further right now. So the external ventilated facade can be chosen freely. You can do whatever you want to. Vapor tight external finishes can cause massive condensation if we're having not a ventilated facade. Yeah, so if you're using here a polymer render that is watertight, yeah, that the vapor tightness is really, really high, then we are running into risk in cold climates. If you're using a metal finish that is directly on our thermal insulation, again, we're running into trouble. Yeah, so this is the risk that we have to look at, and this is the way that it works. The only thing that you have to do difference from a really mild climate to an extremely harsh climate is the thermal insulation thickness. That's the only difference. There is no difference anywhere.